question is, what if sharing doesn't work? What if, in fact, they're not all nonmetals? All right. So what we want to happen is we want the atoms, or the atoms want to become stable. However, it's the thing about equal sharing that kind of messes with this. Sometimes, even with equal sharing, it's just not going to fill the outermost energy level. And that's the goal, right? So, if in fact they can't share to become stable, what it's going to do is some of them need to give up electrons to other atoms that need them. All right? Now, this goes back to the very beginning of this chemistry unit. Do you remember what an atom is called that has gained or lost electrons? See if you remember. This was on the test too. Most of you guys got it right, I think. An ion. And a cation is a positive ion, and an anion is a negative ion. Right? So this is why ions form, is because of this bonding. All right? So this type of bond is called an ionic bond. Some of the atoms have to give up some electrons to other atoms that need this, but in the process, they both become stable, they both become happy, and everybody's good. So let's see how this works. All right. Oops, ionic bonding. Remember, in this type of bond, some atoms lose and other atoms gain electrons. In this case, an atom gains an electron to fill its outer energy level. So let's take a look at chlorine again, which we've seen before. Right, so we have our original chlorine, which with its 7 valence electrons. This green electron comes in from someplace, adds itself to the chlorine's outer energy level in the s and p orbitals, and the chlorine has a filled outer energy level, and it is happy. But it's also negative, because it used to have equal numbers of protons and electrons. Now it has 1 more electron than it did before. Hence, that's why it's negative. So this is a chlorine ion, or a chlorine anion. Notice in the drawing that the chlorine now with the negative sign has little brackets around it, and that's a difference in the way you draw ionic bonds. So in the earlier one, when we were talking about covalent, and I said that the Venn diagrams weren't required, they're not. But in this particular case, the brackets are required. All right, so here's an atom gaining an electron from somewhere. Let's talk about ones that might have to lose them. All right. So let's take a look at sodium. Sodium you find in the alkali metals. It has 1 valence electron, and so it's not stable because it doesn't have a filled outer energy level. So the easiest thing for sodium to do, instead of gaining 7, which is impossible, it's just going to get rid of the one it has. So sodium gets rid of that, and in the process loses one of its electrons. So now it no longer has the same number of electrons as protons. The overall charge becomes positive, and you've got the brackets around the Na. Okay, so this is a sodium ion or a sodium cation. All right, and we talked about this in class last week, but let's look at it again just for clarity. All right, I know what you're thinking. Hey, wait a minute, this atom doesn't have a filled outer energy level. It's actually empty. What's the story with that? Well, remember where we talked about the history of the atom and how the different models were good at allowing us to visualize the atom in different ways. Well, here, even though we know the Bohr model is not actually true anymore, it's still an easy way for us to talk about electrons and where they're found and how they interact and that kind of thing. So here's a Bohr model of a sodium atom. It has 3 energy levels. We're not looking at orbitals here, although I guess you could say the first one is an s orbital. But this energy level includes both the s and the p, and there are in fact 8 electrons in the second energy level. And in the third energy level, however, there's only 1. Okay? So what happens is the sodium will give that outermost electron away, and at that point, the second energy level becomes the outer energy level, and the second energy level is already filled. So and it becomes positive because it has one less negative than it did before. All right, so if sodium wants to get rid of one and chlorine wants one, chances are they probably hang out with each other every now and then. So let's take a look at this. Okay, so where do the extra electrons come? And when somebody loses one, where do they go? This is what makes the bond, right? So you can see our sodium atom with its 1 valence electron, our chlorine atom with 7 valence electrons. The sodium gives up its valence electron to chlorine. The sodium becomes positive. The chlorine becomes negative. Notice the brackets. Okay, so now what's happening is the sodium they both become stable, which is really what they want. But in the meantime, the sodium becomes positive, and the chlorine becomes negative, and they're oppositely charged ions. So one's a cation, one's an anion. And so here's the question, what do you know about opposite charges? You know this. Okay, they attract. So the sodium is attracted to the chlorine and vice versa, and this is the bond. That's what keeps them together, is this positive and negative charge. Now, it's not as strong a bond as the covalent bond, because, for example, NaCl, do you know what that is? Table salt. Okay. Once it's put in water, they separate. They call dissociate. And so anyway, so the opposite charges keep them together. And the chemical equation for this is Na plus Cl yields NaCl, which is table salt. All right. So, just like with the covalent bonds, this does not have to happen simply between one atom and one other atom. It can happen between multiples. So let's take a look at that. All right. So let's go back to chlorine again. Okay, calcium chloride. This actually, this is the stuff that you can sprinkle on your walkway to help melt the ice. So calcium is the alkaline earth metals. It has 2 valence electrons, and chlorine is the halogen, so that has 7 valence electrons. So calcium has 2. It can either get rid of the 2 or try to gather up 6, which it's just not going to do. So the calcium actually says, great, I'll give 1 of my valence electrons to this chlorine atom, and I'll give another one to this chlorine atom, which is great. And so we show the calcium now with no valence electrons. Is that really true? No. What happens is the next valence level in is the full one, but we just don't draw those. It's all about the original ones. All right? So the calcium gave its 2 valence electrons to the chlorine. All right? Because the calcium lost 2 electrons, remember the electrons and protons used to be the same, now it's lost 2. It actually has a +2 charge, which you can see is drawn, or written rather, outside the brackets on the right-hand side of the calcium. Each of the chlorines has gained electrons, so they each have a -1 charge. And so you can see that negative sign on the outside of the chlorine brackets. And if it's 1, you don't have to put a 1. You can just put minus. It's like math with the variables. If it's a 1x, you can just put x. So now the question comes up, why is the calcium ion in between the 2 chlorine ions? And if you look at the charges, this should make some sense to you. Think. All right, because the positive calcium is going to separate the 2 negative chlorines, because what do you know about like charges? They repel. Right. So the chlorines don't want to hang around with each other. They're both really negative, and nobody wants to hang around. No, they don't want to hang around with each other. So that's why the calcium's in the middle, and you need to understand that. Now, but we already used chlorine in the earlier examples when we were talking about covalent bonds. So how does a chlorine atom know whether to ionically bond or covalently bond, if it can do both? Okay, here's another rule. Let's take a look. All right, so here we are back at the coloring sheet. The ionic bonds that we have drawn now between sodium and chlorine, or between what else did we do? I can't remember. Between sodium and chlorine and calcium and chlorine, okay, those are actually metals and nonmetals. So the rule to follow here is to find the elements that you are bonding on the periodic table. If they are both metals and nonmetals, then you're going to be forming an ionic bond. All right? So those are the two rules. If they're two nonmetals, they form covalent bonds. If there are metals and nonmetals, they're going to form an ionic bond. All right?